All right, let's just jump right in. For about 100 years, we've all been told the same story about our universe, right? It started with a Big Bang, and it's been expanding ever since. But what if that entire story, the very foundation of modern cosmology, is just plain wrong? What if our cosmos isn't some chaotic, ever-growing explosion, but is actually a stable condensate, a structure in a state of what's called absolute stasis? It's a radical, thought-provoking idea, and it's the core of a framework known as the Emergent Toroidal Universe, or ETU for short. And this image? Wow, it just lays out the two competing ideas perfectly. On the left, you've got the standard model. It's messy, random, chaotic. But on the right, that's the ETU model, a beautiful, ordered, resonant lattice. See the French text at the top? It says topology precedes dynamics. And that's the whole game changer right there. It means the universe's geometric shape comes first, and that shape dictates all the rules. It's not a random explosion, it's a finely tuned, resonant cavity. So let's really dig into this challenge to cosmic expansion, because, this isn't just some casual thought experiment. It's a full-blown mathematical framework, and it makes some incredibly bold claims that its creators say are backed up by just overwhelming statistical proof. And when they say overwhelming, they are not kidding. Look at these numbers. That 0.998, that's the Pearson correlation. Basically, it measures how well the model fits the actual data we observe. A 1 is a perfect score, so 0.998 is unbelievably close. Then there's the Bayes factor of 1540. In science, when you're comparing two theories, any score over 100 is considered decisive evidence. It's a slam dunk. This is why they make that bold statement at the bottom. This isn't just an approximation. It's an exact measure. Okay, so if the universe is this perfect, static, resonant structure, what's the magic glue holding it all together? Well, the framework introduces what it calls a code of creation, named the Gerard Protocol. And this entire code is built on just 3 fundamental constants. First up, we have a frequency 57.8 gigahertz. Now, this isn't some number they pulled out of a hat. The theory actually derives it from the spectral properties of molecular oxygen. It proposes this is the universe's one true, fundamental stasis frequency, the specific vibration where matter can achieve stability. Next, to hold that stable structure, you need some serious cosmic scaffolding. The protocol calls for an incredibly powerful magnetic field, 4.2 Tesla. This acts as a magnetic confinement, providing the raw structural integrity needed to keep the fabric of space-time locked into its stable donut-like toroidal shape. And finally, we get to the secret sauce, the master key that governs the whole system. It's a transition constant of about 2.87%, and they give it this unique symbol, the section sign, sigma. This one little number is the key that makes the entire model work. So what is phi, really? Think of it as the ultimate tipping point. It's the exact saturation threshold where the universe snaps, from a state of random, chaotic noise into a perfectly locked, stable, stationary resonance. The source material calls it the fundamental elasticity of spacetime's fabric. It's the one rule that turns pure chaos into a coherent, ordered reality. All right, so we've got the code, the fundamental rules, but how does a set of rules and constants become, well, stuff, stars, planets, people? The ETU model says that matter isn't a separate thing at all. It's actually an emergent property of pure geometry. The whole process begins with what the theory calls the skeleton. In mathematical terms, this is a Laplacian grid. Now, the Laplacian is just a way to describe how energy flows and spreads out. So this grid, it's like the fundamental blueprint for the universe. It sets up the basic scales and all the possible ways that energy is allowed to vibrate. So, once you have the skeleton, you need to add the flesh. This is where the Jacobian compression comes in. The Jacobian is a mathematical tool that describes stretching, twisting, and squeezing. In this model, it acts like a geometric press, creating these tiny folds in the fabric of spacetime that literally amplify density, concentrating energy in specific spots without having to add any new material. And here you can see how it all comes together. This equation shows the Laplacian's blueprint and the Jacobian's compression working in concert. In this model, matter, literally, emerges from the wrinkles and folds in spacetime's geometry. And here's the kicker. If this is true, the model says you don't need to invent things like dark matter to explain why galaxies hold together. It's just a natural feature of the underlying geometry. Okay, I know what you might be thinking. A universe made of mathematical folds in a resonant field? It all sounds incredibly abstract, right? But the people behind this framework claim this isn't just a theory on a blackboard. It has real, concrete technological applications that are being put to the test as we speak. And this quote just captures that idea perfectly. Even if you're skeptical about the whole static universe claim on the grandest scale, the mathematical tools built for the ETU model are already making waves. They are pushing the boundaries of what we thought was possible in high-energy physics right here, right now, in the lab. So what are these breakthroughs? Well, for starters, in the hunt for clean fusion energy, applying these ETU principles has apparently led to record-setting stability in plasma reactors. Then, that very same 57.8 gigahertz resonance frequency. It's being used to perform logic operations in next-gen computers using these tiny magnetic whorls called skymuriums. And maybe most stunningly, the model was used to predict the exact spectral signatures of carbon out in space, which were then matched to observations from the James Webb Space Telescope with what they call sub-QCD precision. That means an accuracy that's even better than our standard model of physics can explain. So we've gone through the physics, the math, the technology, but all of it leads to the most profound and maybe the most challenging implications of the whole ETU framework. What it all suggests about the fundamental nature of existence itself, about ontology. And here's the bottom line. According to the ETU, being isn't about substance. It's not about particles. It's about frequency. The model claims that what we call reality is nothing more than a sustained, stable state of phase-locked resonance. Everything we are, everything we see, only exists because it's part of this one universal, stable vibration. And get this, if reality is a stable geometric structure, then information can't ever really be lost. It is structurally encoded into the global shape of the universe, in what the theory calls the eternity register. The idea is that information isn't fleeting, it's woven permanently into the very fabric of the cosmos. In this view, information is truly immortal. And this leaves us with one final, absolutely mind-bending question. If we as a species can truly understand and start to apply these rules of a resonant reality, if we can use this Girard protocol to actually manipulate energy and information at a fundamental level, then at what point do we stop being just passive observers of our universe? At what point do we become its architects?